Okay, so we're going to pick up on our 9.1 notes, solving systems of equations, and we're going to talk about how to solve systems of equations. So to solve a system of equation, there are three ways, and we're going to look at all three. So the first way, which is what 9.1 is on, is by graphing. And so we're going to graph the two systems and find where they intersect, and that will be the solution. The second way is a method called substitution, and this will be 9.2 that we cover it. And the third way is either called the elimination, or another name for it is the addition method. Okay, and that will be in 9.3. So in 9.1, we're going to focus on graphing. Okay, so by graphing, we're going to write out all of the steps for how we graph it. So the first thing is we use our techniques for graphing and we graph the first equation. And you can pick how you want to graph it. You can use slope-intercept form. You can use the x and y intercepts, whichever way you find easiest to graph. Then we are going to graph the second equation. And then if there is a solution, what will happen is if I have a graph and I graph the two equations, if they intersect at a single point, then there's one solution. And whatever this point is the solution. So what we're going to do is we are going to look and find, if there is one, the point of intersection. So we're going to identify the point where they intersect. That xy, this is the solution. And we're going to write it as a point, x, comma, y. And then once we find the solution, we are going to check it. And we check it by substituting xy into both equations. And it's important to check both of them because it could work for one and not the other if you made a mistake somewhere. Okay. So these are the 4 steps. You may need to pause right now to be able to write them down before moving on to the next slide, but these are the 4 steps for graphing. Now, 2 special cases will occur. Okay. So if the lines are parallel, and so that looks like if I have my graph, 2 lines that run in the same direction and never intersect. That's the definition of parallel. If 2 lines are parallel, there is no point of intersection since they never cross, and this is an example of no solution. And this occurs when they have the same slope. If you have 2 lines with the same slope, they will be parallel and there's no solution. The other case that will result is if 2 equations result in the exact same line, we say there are infinite solutions there's an infinite number of points that work. So what that looks like is you'll graph one of the lines and you'll get like a line here. And then you'll go to graph the other line and you'll realize that you are getting the exact same line. It has the exact same slope and the exact same y-intercept. And because of that, there are like an infinite number of points on this line that makes both equations true. And so that means there's an infinite solution. It doesn't mean any point is a solution. Like if you have a point over here, that's not a solution. It just means that there's an infinite number of points on these lines that work for both equations. Again, it's not any point, there's just an infinite number of points that work. So I'm going to do one example in this video, and then I'll do a few more examples in another video. So we're going to solve the following system equations by graphing, and you'll be given a graph. Okay. So we're going to graph these two. You can pick your method, but generally if it's y equals, the easiest way is to use our slope-intercept form, where it's y equals mx plus b. And we identify our m and our b. So for this first line, y equals negative 5x plus 3. My m is negative 5 over 3, and my b is positive 3. Remember, we always start with the b, and the b is the y-intercept, where my graph crosses the y-axis. So I'm going to go to 3 on the y-axis, which is here, and I make my first point. Then to get my second point, I use the slope. Okay, so the slope is negative 5 over 3. Remember, the slope, which is m, stands for rise over run. And the top number always tells me up or down because it's negative, and we usually just put the negative with the top number. We're going to go down 5, and then the bottom number is going to be positive. Don't put two negatives because two negatives make a positive, so only one of them is negative. And that is a positive 3, so we're going to go right 3. Okay, and so from this point, we always start at the y-intercept. We're going to go down 5, right 3, make a second point, and then draw our line. Okay, and for these, if you can count it again, like going down 5, right 3 occurs on your graph again, I recommend making more points so that your line is exact, because that's going to matter for these problems. So my second line is 1/3 x minus 3. Okay, so in this case, my m is 1 over 3. That's, again, m stands for slope. My b is, keep that negative sign with it, negative 3. And that, again, is my y-intercept. So negative 3 is where we are going to start with this line on the y-axis. Okay, so we always start with our y-intercept, and then we're going to count. So 1/3 means we go up 1, right 3. So we're going to go up 1, right 3. And you want to count until you intersect the other line. So this one does it right away. If not, you might have to count out your slope multiple times. We're going to draw both lines. And then the solution, which is the whole point of this, so make sure you state it, the solution is the point where they intersect. So I'm going to identify this point. So the x value, if I look where they intersect, is 3. And the y value, if I look on the y-axis, is negative 2. So the solution is 3, negative 2. And that's how we find the solution. And then it is a good idea to just check and make sure that it works for both equations. That's like our step 4. So we have y equals negative 5/3 x plus 3. And my second equation was y equals 1/3 x minus 3. So to check it, I'm going to plug in, this is my x, this is my y. So I'm going to plug in negative 2 for y and 3 for x. And then we're going to multiply this. So we need to do negative 5/3 times 3. So one thing you could realize is because we have divide by 3 and multiply by 3, that the 3's cancel, and we just get negative 5. Or if you don't realize that, remember when we multiply fractions, we put this over 1, and then we multiply, again, numerators together, denominators, so it's negative 15 over 3. And then we divide, so negative 15 divided by 3 is negative 5. And we get negative 2, negative 5 plus 3 is negative 2. Okay? And so that works. So our first equation checks out, and then we check it in our second. Again, you want to check both. So I plug in negative 2 for y 3 for x. Okay, and then we're gonna simplify that. So however you do, you can cancel the 3's, or you can put 3 over 1, multiply. You can also just multiply this in your calculator. And we get -2 equals 3 divided by 3 is 1. And then 1 minus 3 is -2, and that works. Okay. And so that should be the last step, just to check. Again, our solution is this, but this is just to make sure that we have the right answer. Okay. And that's an example of solving by graphing.